Hi guys, welcome to Skholar IAS, your one-stop solution for UPSC preparation. Myself Biswajit Sir, your faculty for Geography. So in the last class we have started with the topic of distribution of oceans and the continents, where we have talked about the continental drift theory, then we have talked about the mantle convection cell theory, and then we have talked about your seafloor spreading. So today we will continue with the same chapter where we will specifically talk about your plate tectonics theory. Hi guys, so in the last class we have started off understanding about the distribution of oceans and the continents, where we have talked about some major important theories. For example, we have talked about the continental drift theory, we have talked about the seafloor spreading theory as well as the mantle convection cell theory. Then we have also understood how the convection cell theory was a development over the continental drift theory in terms of forces which resulted in movement of the continents, right? So moving on, let us also discuss about a very important theory which is called as the plate tectonics theory, which is considered to be the most apt theory, which talks about or which gives us a better understanding about the movement of the oceans and the continents, right? So the first thing here that we are going to talk about is understand what are your lithospheric plates or your tectonic plates. Then we will talk about your different types of tectonic or your lithospheric plates, right? And then we will also talk about your different types of interactions. And what do I mean by interactions? Interactions between these lithospheric plates. What are the different types of interactions that takes place, whether it moves towards each other, whether it moves away from each other, or rather it moves or it slips past each other, right? And lastly, we will also talk about the movement of the Indian plate, which resulted in formation of the Himalayas, right? So let us understand by first talking about what are lithospheric plates or tectonic plates. So a tectonic plate, which is also called as a lithospheric plate, it is a massive irregularly shaped slab of solid rock which is generally composed of both continents and your oceanic lithosphere. Now what is a lithosphere? We have already understood it is nothing but the crust and upper part of the upper mantle, right? So this lithospheric plate that I am talking about, they can be categorized into three different groups. Firstly, it is totally made up of a continent. Then it is a mixture of both continent as well as ocean. Now ocean, I have shown it as a thinner because it is thin compared to your continent, or it can also be totally made up of oceans, right? So these are the three different types of lithospheric plates that we find, because now we all know that the lithosphere is not a uniform body, but it is broken down into different lithospheric plates, and these plates can be made entirely of continental lithosphere. It can be made as a combination, or it can be found as a combination of continents and oceans, or it can be exclusively made out of oceanic mass. All right, so these are how the three different types of lithospheric plates look like. Fine. But always remember that most of the lithospheric plates which are found across the world, they are found as a combination of continents and ocean crust. Fine. So these plates, of course, they move horizontally over the asthenosphere as rigid units, because if this is a lithosphere, right, below the lithosphere what do we have? We have the asthenosphere, right? And here what do we have? We have the mantle convection cells, right? And because of the upper limbs of the mantle convection cells, this continental or this lithospheric plate will either move to the right or it will move to the left. Understood this? So they move horizontally. So the lithosphere includes the crust and the top mantle, like we have already understood, with its thickness which ranges between 5 and 100 kilometers in the oceanic parts, and it is about your 200 kilometers in the continental areas. Because your oceanic crust is comparatively thinner, or the oceanic lithosphere is thinner, therefore its thickness varies between 5 to 100 kilometers, and your continents being thicker, it is extending up to a height of around your 200 kilometers. Fine. So a plate may be referred to as a continental plate or an oceanic plate, depending upon which of the two occupy a large portion of the plate. So most of the plates are found as a combination of continents and oceans, right? But if the continental portion is much more compared to the ocean part, then we can term it as a continental plate. But if the oceanic part is much more compared to that of your continent part, we can call it as an oceanic plate. Fine. Now Pacific plate, if I have to talk about, is largely an oceanic plate. It does not necessarily mean that it is made up of only oceanic plate, but it also has certain portions of continental plate, but largely it is made up of your oceanic plate, therefore we call it as the oceanic plate, right? Whereas Eurasian plate, it is mostly made up of your continental plate, therefore we call it as a continental plate. That the theory of plate tectonic proposes that the Earth's lithosphere is divided into 7 major and some minor plates. So overall, if I have to look at the Earth in this diagram as shown, the lithosphere are of different types. So we have major plates as well as we have minor plates. Minor means smaller in size, major means it is larger in size. So in this world we have in total 7 major plates and some minor plates. So what are these 7 major plates? Firstly, we have the Antarctica and the surrounding oceanic plate, number 1 major plate. Secondly, we have the North American plate. Then we have the South American plate. Then we have the Pacific plate. Then we have the India, Australia, and New Zealand plate. Then we have the Africa and the Eastern Atlantic floor plate, and then we have the Eurasia and the adjacent oceanic plate. So these are the 7 major lithospheric plates that we see. Then we also have some minor plates. Now this is again very important from your prelims perspective, because you can expect questions about your minor plates compared to that of your major plates, because major plates is known by everyone, but minor plates needs to be better understood. For example, we have a Cocos plate. Now where is this Cocos plate located? It is found between Central America and the Pacific plate. Fine, very important for you to understand its location. So this is where we have the Coco plate between Central America and the Pacific plate. Then we have the Nazca plate, which is found to the south of the Cocos plate, which is again between South America and the Pacific plate. Then we have the Arabian plate, which is mostly occupying the South Arabian landmass. Then we have the Philippine plate, which is between your Asiatic and the Pacific plate. Then we have the Caroline plate, very important, which is found between the Philippine and the Indian plate to the north of New Guinea. Then we have the Fuji plate, which is found to the northeast of Australia. And these plates have been constantly moving over the globe throughout the history of the Earth. This movement, why it takes place, we will understand, and how and what type of movements happens, we will also look into this. And it is not the continent that moves as believed by the Wagner. So it is not the continents that are only moving, but it is the continents, the oceans, overall it is moving, and the forces behind its movement are also different. Now since we have understood what are lithospheric plates, right? Now suppose this is a lithospheric plate, this is another lithospheric plate. So this section that you see here, where there is a boundary between lithospheric plate 1 and lithospheric plate 2, we call this as the boundary, right? And within this boundary there can be different types of interactions. Suppose L1 and L2 can move towards each other, L1 and L2 can move away from each other, or it can move slide past each other, right? Therefore we call this as different types of boundary interactions referring to your movements, right? So we will understand different types of movement. So for you have to understand that there are 3 basic important movements or plate boundary interactions. The first one is called as your divergent. Then we have a convergent interaction. Divergent means what? Divergence means the plates are moving away from each other. Convergent means they are moving towards each other, right? And then we have your transform boundary interaction. Transform meaning they are sliding past each other. Fine. So let us understand this one by one. So where new crust is generated as the plates pull away from each other, we call this as the divergent boundary, right? Suppose this is a continental plate, or sorry, if suppose this is a lithospheric plate 1 L1, this is a lithospheric plate L2. Now divergent means what? It means that they are moving away from each other. And why it moves away from each other, or how? Because below L1 and L2 we have mantle convection cells C1 and C2. Okay, so how it happens? In the upper limbs, if you notice, in the upper limbs of C1 and C2, both are moving away from each other, and therefore L1 and L2 will move away from each other. And because of this, what will happen? Between L1 and L2, as it moves away from each other, in between we will have magmatic intrusion, right? this magma will flow in both the direction, which will give us a new crust. When this lava will cool down, it will give us a new crust, and this is how your ocean floors are being formed, like we have seen in the last class, right? So divergent boundary, always remember, it results in formation of new crust. Very, very important, especially oceanic crust, right? So the sites where the plates move away from each other are called as the spreading sites. The best known example of divergent boundaries is the mid-Atlantic ridge. Here we have South America, here we have Africa, both are moving away from each other, right? And therefore the Atlantic Ocean is spreading. Fine. At this, then we have the American plates, which are separated from the Eurasian as well as the African plates. Then we have the convergent boundaries where the crust is destroyed. Okay, let me rub this first, then I will go to convergent boundary. Convergent boundaries where the crust is destroyed as one plate dives into another. Now L1 lithospheric plate, L2 is a lithospheric plate. Below this we have two mantle convection cells which are moving towards each other, C1 and C2. Now as the upper limbs are moving towards each other, meaning L1 and L2 will now collide, and because of this collision, what will happen? Your destruction will take place. Understood? So divergent boundary talks about formation of new crust, whereas convergent boundary talks about your destruction of the crust. Very, very important. Fine. The location where sinking of a plate occurs is called as the subduction zone. For an example, if I have a continental plate here, C1, and if I have a oceanic plate here, O1, and if O1 and C1 are moving towards each other, which one will fall down? Of course, your O, that is the ocean plate, will move below the continental plate, and these locations are called as what? These locations are called as trenches. And why the ocean plate is moving below your continental plate? Because your density of ocean floor is greater than density of your continents, right? And these areas or the trenches, they are called as the subduction zones. And there are three ways in which your convergence can occur. Firstly, between an ocean and a continental plate. Okay, so convergence can take place between oceanic and a continental plate, like as shown in this diagram. Then convergence can also take place between two oceanic plates, or your convergence can also take place between two different continental plates, right? So this was all about your divergent and convergent boundaries. Then the last type of interactions that we have is called as your transform boundary interaction, where the crust is neither produced or destroyed. When it is produced in case of your divergent boundary, it is destroyed in case of your convergent boundary, right? But in case of your transform boundary, there is neither production nor there is destruction. Fine, because here the plates will slide horizontally past each other. If this is a lithospheric plate L1 and if this is a lithospheric plate L2, they will slide past each other. They will neither move towards each other or away from each other. They will slide past each other. Fine. The transform faults are planes of separation generally perpendicular to the mid-oceanic ridges. As the eruption do not take all along the entire crust at the same time, there is a differential movement of the portion of the plate away from the axis of the earth. Now, transform faults or your transform boundaries are also found or majorly found along the mid-oceanic regions, ridges. For example, if this is the ocean flow, right, here is the continent 1, here we have continent 2, here we have the ocean. This mid-oceanic ridge that you see here, this mid-oceanic ridge, it is not a continuous mid-oceanic ridges, it is not a uniform body, but rather it is broken down into different parts like this, because of the movement of the crust is not uniform, and these areas, it results in formation of the faults, which we call it as the transform faults. Understood? So transform faults are planes of separation, meaning this section of the mid-oceanic ridge is being separated from this mid-oceanic ridge. So now this and this is part of the same mid-oceanic ridges, but as the crust is moving not uniformly, therefore it results in formation of faults, and these faults are called as the transform faults. Understood? So transform faults are planes of separation generally perpendicular to the mid-oceanic ridges, and as the eruptions do not take along the entire crust at the same time, there is a differential movement of the portion of the plate away from the axis of the earth. Understood? And also the rotation of the earth has its effect on the separated block of the plate portions. So I hope you have understood what a transform faults. Now this portion again not very important from your examination perspective, but you still have to understand this, the rate at which the plates are moving. The strips of normal and reverse magnetic fields that are parallel the mid-oceanic ridges help the scientists determine the rates of the plate movement. Fine. These rates vary considerably. The Arctic ridge, for an example, has the slowest rate about your 2.5 centimeter per year. Then we have the East Pacific rise near the Easter Island in the South Pacific, about your 3400 kilometer west of Chile, which is the fastest, which is about your 15 centimeter per year. So the plate movement varies between 2.5 centimeter per year to up to how much? 15 centimeter per year. Understood? Now what are these forces behind the movement of the plate? Now this we have already understood. This is nothing but related to the mantle convection cells as given by a person whose name was Arthur Holmes, right? So let us just go through the points because we have already understood this. So at the time that Wegener proposed his theory of continental drift, most scientists believed that the earth was solid, motionless body. However, concepts of seafloor spreading and the unified theory of plate tectonics has emphasized that both the surface of the earth and the interiors are not static and motionless, but they are very, very dynamic in nature. The fact that the plates move is now a well accepted fact because of the convection cells. The mobile rock beneath the rigid plates is believed to be moving in a circular manner, that is the convection cells. The heated material rises to the surface, spreads and begins to cool, and then sinks back into deeper depths, right? Because it rises, it moves, then it gets cooled down and it sinks, forming a convection cell. This cycle is repeated over and over to generate what scientists call a convection cell or a convection flow. Your heat within the earth comes from two main sources. One is because of your radioactive decay and another one is because of your residual heat. Arthur Holmes first considered this idea in the 1930s, which later influenced Harry Hayes's thinking about seafloor spreading. The slow movement of hot softened mantle that lies below the rigid place is the driving force behind the plate movement. Okay, so this was all about the plate tectonic theory. Now let us talk specifically about the movement of the Indian plate. Fine. Okay, so the Indian plate basically includes the peninsular India, the Australian continental portions as well. Fine. And it also includes the New Zealand. The subduction zone along the Himalayas forms the northern plate boundary in the form of the continent-continent convergence. In the east, okay, now basically it is talking about the boundary of the Indian plate. In the north it is bounded by the Himalayas. Then in the east it is bounded by the Rakhine mountains of Myanmar, right, towards the island arc along the Java Trench. Here we have the Java Trench. Then the eastern margin is spreading site lying to the east of Australia in the form of oceanic ridge in the southwest Pacific. Then the western margin follows the Kirthar mountain of Pakistan. Here the Kirthar mountain of Pakistan. It further extends along the Moroccan coast and joins spreading sites from the Red Sea Rift. Here we have the Red Sea Rift, right, southeast along the Chagos archipelago. The boundary between India and the Antarctic plate is also marked by your oceanic ridge, that is a divergent boundary running roughly in the west-east direction and merging into the spreading side a little south of New Zealand. So here we will have the southern boundary which is along the Antarctic plate. Fine. Now what is important from your examination perspective is the movement of the Indian plate. Fine. So this is what will be asked in your exam. It can be expected both in your prelims as well as in your mains, right? So India was a large island which was situated off the Australian coast in the vast ocean in the earlier times. Then the Tethys Sea separated it from the Asian continent till about your 225 million years ago. Then India is supposed to have started its northward journey about 200 million years ago at the time when the Pangaea broke. So as the Pangaea broke, the Indian plate started moving in the northward direction towards the Eurasian plate. And in between what did we have? We had the Tethys Sea, right? And when this journey took place, it took place about your 200 million years ago. Fine. Then what happened, as the Indian plate started to move towards the Eurasian plate around your 40 to 50 million years ago. India collided with Asia about 40 to 50 million years ago, causing rapid upliftment of the Himalayas. So as the Indian plate moved over the Tethys Sea, it collided with the Eurasian plate. So here in the north we had the Eurasian plate, in between we had the Tethys Sea, and here we had the Indian plate. So this Indian plate now moved towards the Eurasian plate, and because of this, what happened, this Tethys Sea rose in height, and these sediments got accumulated in a vertical direction, which resulted in formation of the Himalayas. Understood? The positions of India since 71 million years till the present are shown in the figure. So around 71 million years ago it was present somewhere here. Then again it was moving in the northward direction towards the Eurasian plate and collided about 40 to 50 million years ago. Understood? Very simple. Alright, next point, the two major plates were separated by the Tethys Sea, like we have already seen in the diagram, and the Tibetan block was closer to the Asiatic landmass. During the movement of the Indian plate towards the Eurasian plate, a major event that occurred was outpouring of lava and formation of the Deccan Trap. So basically what happened, this is the Indian plate. As the Indian plate was moving towards the Eurasian plate, it moved over a hot spot called as the Reunion Island, which is a volcanic island. So as the Indian plate moved over the Reunion Island in the northwestern portion of the Indian peninsula, it resulted in eruption of basaltic lava, and when this basaltic lava cooled down, it resulted in formation of igneous rocks, and this region is called as the Deccan Traps, right? So this started somewhere about your 60 million years ago and continued for a very long period of time. Okay, the continent was still closer to the equator at this point. From 40 million years ago and thereafter, the event of formation of the Himalayas took place, and scientists believe that the process is still continuing and the height of the Himalaya is still rising even to the date, because Indian plate is still now converging with the Eurasian plate, and because of this the height of the Himalayas are continuously increasing even in today's time. Fine. So here you have to understand two important things. First, the formation of the Himalayas, and secondly what you have to understand is about the formation of the Deccan Traps, which was resulted because of the Indian plate moving over the reunion hotspot, which resulted in volcanic eruption in the northwestern portion of the Indian peninsula. So before we conclude, let us deal with two very important questions. First, which of the following is not a minor plate? We have Nazca, we have Philippines, we have Arabia, we have Antarctica. Of course, Antarctica plate is not a minor plate. Then which of the following is type of a plate boundary of the Indian plate along the Himalayan mountains? Ocean continent convergence, divergent boundary, transform boundary, or continent continent convergence? What is it? Which of the following is the type of plate boundary of the Indian plate along the Himalayan mountains? It is your continent continent convergence, because your Eurasian plate is colliding with the Indian plate. So both are made up of continents, right? So we will call it as your continent continent convergence. Understood? So this is where we will end. Thank you. So I hope you understood today's topic of plate tectonics theory, where firstly we have talked about the lithosphere being broken down into different fragments, which are called as your lithospheric plates. Then moving on, we have also talked about how these plates interact with each other, or which is also called as your plate boundary interactions. So with this, we are done with the topic of distribution of oceans and the continents, and in the next class we will start off with a new topic which is called as your minerals and rocks.